We're going to go ahead and start with properties of continuous functions. If the functions f and g are continuous at a point x equal to c, then the following algebraic combinations are continuous at x equal to c. If we add the two functions, then the resulting function will be continuous at c, because the two functions are continuous at c. Their difference also will be continuous at c. If we multiply one of them by a constant, then the result is continuous at c. If we multiply the two functions, then the product of the two functions must also be continuous at c. If we take a ratio between these two functions, like f divided by g, then we should make sure that g of c is not equal to 0. And that's the way that you can guarantee that the ratio between them is continuous at c. If we are raising a function to the power n, then n must be positive, because if it is negative, we will have a denominator and there is a chance that discontinuity may be introduced by the denominator. If we are taking the nth root of a function, then there are two conditions. Number one, n must be positive, because if it is negative, then we will have a denominator which will also may result in discontinuity. And the second situation is that since we are taking the root, then the interval might get smaller and smaller. We have to make sure that for this to be satisfied, that is the nth root of the function to be continuous at c, c must be within the interval, because the root will reduce the interval. So c must be within the interval. And the second condition, n must be positive. These are important conditions, and we will see them when we will move on to the composite functions. Composition of continuous functions. If f is continuous at c and g is continuous at f of c, then the composite g circle f is continuous at c. We will take an example or some examples to prove this, but before, let's take a look at some of the remarks. Number one, all elementary functions and all functions that are obtained by subtracting, dividing, multiplying, and taking composition of elementary functions are continuous over the natural domain. Elementary functions are powers of x, roots of x, absolute value function, logarithmic functions, exponential functions, trigonometric, and inverse trigonometric functions. Let's start looking at some of the examples. Here is the first example to look at. At what points are the following functions continuous? Y equal to square root of x squared minus 2x minus 3. Since the square root of negative numbers is excluded at this level, at this course, we have to exclude all the values of x that result in square roots of negative numbers. Therefore, we must keep x squared minus 2x minus 3 greater than or equal to 0. The equation x squared minus 2x minus 3 can be factored into x minus 3 multiplied by x plus 1, and these two factors imply that x equal to 3 and x equal to negative 1 are solutions that result in y equal to 0. As such, x greater than or equal to 3 and x less than or equal to negative 1 are sections of the function that are continuous. We conclude that the section in the open interval from negative 1 to 3 open interval is not continuous. Thus, the function is continuous in the interval from minus infinity to negative 1, including negative 1, union the interval from 3 to infinity, including 3. That's it for the first part A. For part B, the function is continuous everywhere because both the numerator and the denominator will remain positive regardless of the values of x. Why? Because x is raised to an even power and x in the numerator is raised to an even power also, even though we might get x cubed to be a negative number, but then we have to square that. So since the numerator and the denominator will always be positive regardless of the value of x, then the function is continuous everywhere. So the function is continuous everywhere because both the numerator and denominator will remain positive regardless of the values of x. Thus, the function is continuous in the interval from minus infinity to plus infinity. Continue to investigate functions for the portions of the functions that are continuous. Here, the same question, at which points are the following functions continuous? A, y equal to absolute value of the ratio between x minus 2 and x squared minus 2. This function is continuous everywhere except at the point x equal to square root of 2. Therefore, the function is continuous in the interval, open interval, from negative infinity to square root of 2, open interval, union, open interval, from square root of 2 to plus infinity. For D, we have y equal to the absolute value of the ratio between x sine x, that's divided by x squared plus 2. This function is also continuous everywhere and its interval is from negative infinity to infinity. Now we will move ahead to examine limits of continuous functions one more time. If g is continuous at the point B and limit as x goes to c of the function f of x is equal to b, then limit as x goes to c of the composite function g f of x equal to g of b, and that's equal to g of the limit as x approaches c of the function f of x. Example 9. As an application of theorem 10, which is this theorem, we have the following calculations. Number 1, we want to figure out the limit as x approaches pi over 2 of cosine of 2x plus sine of 3 pi divided by 2 plus x. Close the parenthesis for the sine, close the parenthesis for the cosine. Now we could go ahead and rewrite this as cosine, and then we take the limit inside because 2x will be impacted by the limit. So that will be cosine, and then open the parenthesis. We take limit as x approaches pi by 2 of the 2x plus, this is another function, so we'll take the limit inside the parameters of the sine also. So this will be plus sine, and then 3 pi over 2 is not impacted by the limit, so we will not include it. The limit will only be for the x. So it will be limit as x goes to pi over 2 of x. One more time. We have to take the limit inside the function. So the first time we took the limit, we have to take it to take care of the limit for 2x. And then we have to also apply the limit to the second part of the parameter, which is sine. But then since it is sine, so we'll take the limit inside. This is a constant, so we don't need to get the limit for the constant because it is equal to the constant. So we have to get the limit for x only. And that's what we did over here. Now all we have to do is we just have to manipulate them. We can see that we will have cosine, and then we have here the limit as x approaches pi over 2 of 2x, that will give us pi. So the first limit will give us pi plus sine, and then we have the second limit will give us pi divided by 2 plus 3 pi divided by 2. That's 4 pi divided by 2. That means that's 2 pi. So we have 2 pi over here. So in conclusion, we have cosine of pi plus sine of 2 pi. Sine of 2 pi is equal to 0. So this will give us just cosine of pi, and that's equal to -1. We'll continue on the limits. So let's take a look at the next problem. We want to figure out limit as x approaches 1 of arc sine of 1 minus x divided by 1 minus x squared. This will be equal to, we have to keep sine inverse of, and we have to apply the limit to its parameters. So this will be limit as x approaches 1 of 1 minus x divided by 1 minus x squared. We could go ahead and say that this is equal to sine inverse of limit as x goes to 1 of 1 divided by 1 plus x. And how did we get 1 plus x? We factor out 1 minus x squared. So it will factor to 1 minus x multiplied by 1 plus x. 1 minus x cancels 1 minus x, and we'll have 1 in the numerator, and denominator will be 1 plus x. Now we have to apply the limit, and we replace every x by 1, so that will be 1 divided by 2. So we'll have the arc sine of half, but arc sine of half is equal to pi over 3. The second question is, we want the limit as x approaches 0 of the square root of x plus 1 multiplied by e to the tan x. This we can deal with in the same manner. We have to take the limit inside and apply it on the x, and also we have to take the limit on the second term, which is e to the tan x. We have to apply it at the x. So we will have limit of x as x goes to 0. So the first part will be equal to 0. Plus we have 1. So we have the square root of 1. Square root of 1 will give us 1. Now we have e to the tan. We have to apply the limit, okay, on the x. So we have limit as x goes to 0 of x. That's going to give us 0. So it will be tan 0. But tan 0 is equal to 0. And that means e will be raised to the power 0. So the first is going to give us square root of 1, which is 1. And the second will give us e to the 0, which is also equal to 1. So square root of 1 multiplied by 1 will give us 1, and that's the limit equals to. Okay, limit as x approaches -7. Yeah, just plug in, don't worry. This one you don't have to plug in, right? Because if you plug in, we'll be in trouble, right? So what do we do?
X minus 5 over x minus 5.
Yeah, x minus 5, x plus 5, right?
1 over x plus 5.
So it will be what?
1 over 2.
It will be x minus 5 divided by x minus 5, x plus 5, right? Right? This goes right?
Yes, 1x plus 5.
1 over 10. Right?
Yes, sir.
Everybody? Okay, good. Let's go to the next. Okay, the next one. Hi, Shabab. Limit. Limit the second one. Hi, Shabab.
X
We have
T plus 2 plus 1 and plus 2.
t plus 2, t minus 1,
T minus 1.
divided by t,
T squared.
t minus 1, t plus 1. Right? This is gone, then you just replace it. Right? Okay, that's good. Okay, let's take a look at the rest next. Okay? Do we have to do this one?
Correct.
Let's just leave it. Okay, what about this? Okay, should we do it? Okay, let's do it. What does it say? Square root of 5h plus 4. 5h plus 4, right? And then minus 4, minus 2. Minus 2 divided by h. Limit at h plus to 0, right? Obviously, what are we supposed to do? Anytime you have a square root, don't even think, conjugate. So if you do the conjugate, you do what? You multiply this thing by what? By square root of 5h plus 4 plus 2, right? Divided by square root of what? 5h plus 4 plus 2, right? So the top is going to give me what?
5h plus 4.
5h plus 4
Minus above.
minus 2,
Plus 2.
okay, plus 2, right? About
Minus 2 minus 2.
so, yeah, you did it all wrong. So minus 2, that's fine. Okay, but if you did it step by step, you have to do what? Minus 2,
Minus 2 plus 2.
and then you have minus 2.
Plus 2.
Minus 4.
Minus 4.
Right? Minus 4. And you can just get rid of this one. And that will give you what? 5h minus 2. Okay? Everybody?
There is no minus 2. No.
Why minus 2 that minus 4?
Okay, we multiply this by
5h plus 4
we get
minus
rid of
4.
yeah, we get rid of this, and then we have to square that pieces, right? So if we get rid of this, we're going to get what? 5h
Plus 4 minus 4.
plus 4,
Minus 4.
and then minus 4, right? So that's going to give us what? 5h. 5h divided by h multiplied by 5h plus 4 plus 2. We have to take the limit, right? Now we can substitute, right?
You can take the other.
Yeah. So if we substitute, we're going to get what?
Square root 5 plus
1 over 3, right?
5.
This is 0, right? This is 2.
2 plus 2 so equals 4 and
Okay, so this will be 2 plus 2 equal to 4. So it's 1 over 4.
5 over 5. Numerator is 5.
Oh, this is.
4.
Oh, Oh, this is 5, you're right. Sorry. I was thinking of talking about this. So this is 5 over 4, right? Okay, good. Next. For the following problems, we have to find the limit. To start with, limit as x approach 1 of 1 over x minus 1 divided by x minus 1. We can rewrite this problem as follows, as limit as x approaches 1 of 1 minus x divided by x multiplied by x minus 1. So we can cancel 1 minus x with x minus 1, and that will give us negative 1. So we'll put negative 1 in the numerator, and then the denominator will be left with only x. So negative 1 divided by x, if we take the limit as x approaches 1, will give us negative 1 as the answer. The next problem is limit as y approaches 0 of 5y cubed plus 8y squared divided by 3y to the power 4 minus 16y squared. We can see that we have at least y squared involved with each and every term in the numerator and the denominator. So we can factor out y squared from the denominator, and we can factor out y squared from the numerator. If we do so, we're going to get limit as y approaches 0 of y squared multiplied by 5y plus 8 divided by y squared multiplied by 3y squared minus 16. What we can do is we can just go ahead and cancel y squared with y squared. And if we want to apply the limit y equal to 0, that will cancel 5y and cancel 3y squared. So we'll end up with only 8 divided by negative 16, and that's going to give us negative 0.5, and that's the answer. So the limit is negative 0.5. Next one is we have limit as x approaches 0 of the function 1 divided by x minus 1 plus 1 divided by x plus 1, all divided by x. We can rewrite this function as follows: limit as x approaches 0 of x plus 1 plus x minus 1 divided by x multiplied by the common denominator for these two will be x plus 1 multiplied by x minus 1. We can see that we can add up, we can have 2x, and then 1 minus 1 will cancel each other, so we'll have 2x in the numerator. And denominator is x multiplied by x plus 1 multiplied by x minus 1. So we can cancel the x with the x, and if we do so, we'll be, if we cancel the x with the x, if we do so, we'll be left with 2 in the numerator, and the denominator will be the same. So 2 in the numerator and denominator will be the same, except that we cancel the x. So now we can apply the limit as x goes to 0. So we'll have a 0 from the first bracket, 0 from the second bracket, but then we will end up having negative 1 multiplied by positive 1, and that gives us negative 1. So the numerator is 2, denominator is negative 1, so the answer will be negative 2 for the limit. The next one is limit as x approaches 4 of 4 minus x divided by 5 minus the square root of x squared plus 9. We could go ahead and multiply both the numerator and the denominator by the conjugate of the denominator. And if we do so, the limit will be for x approaching 4 of 4 minus x divided by 5 minus square root of x squared plus 5, which is the function, multiplied by the conjugate of the denominator, and the same value is multiplied by the numerator. Now we could just do the math, and if we do the math, we get x minus 4 multiplied by 5 plus the square root of x squared plus 5 but in the denominator we're going to have just 25 minus x squared minus 5. And if we apply the limit as x approaches 4, if we apply that limit, then we're going to get 0 from the first bracket, and that cancels everything, so numerator will be equal to 0. But the denominator is going to be 25. If we subtract 5 from it, we're going to have 20, and then we plug in 4 over here. That is going to give us 16, so 16 minus 20, the denominator will be equal to 4. Basically, just simple arithmetic. Replace x by 4 and do the math. That will give us in the numerator 4. So 0 divided by 4 is going to be equal to 0, so the limit is equal to 0. We have to figure out the following limits. First, we want the limit as x approaches 0 of 2 sine x minus 1. All we have to do is we have to just plug in for every occurrence of x, we have to plug in 0. So this will yield the limit equal to 2 sine 0 minus 1. 2 sine 0 is equal to 0 minus 1, so the answer is that the limit is equal to negative 1. The second question, we want the limit as x approaches 0 also of 1 plus x plus sine x divided by 3 cosine x. All we have to do is plug in 0 for every x. So we will be getting 1 plus 0 plus sine 0 divided by 3 cosine 0. 1 plus 0 plus sine 0 will give us 1, and 3 cosine 0 will give us 3. So the limit is 1 over 3. The next problem is we're given the limit as x approaches negative 2 of p of x equal to 4, and limit as x approaches negative 2 r of x equal to 0, and limit as x approaches negative 2 s of x equal to negative 3. We want to find the limit as x approaches negative 2 of the sum of the functions. The addition rule states that the limit of the sum of functions is the sum of the limits of the functions. So we'll just go ahead and do the sum of the three limits. We know the first limit is 4, the second limit is 0, the third limit is negative 3. So we will just add, because we're asked for the limit of the sum of the functions. So that's equal to the sum of the limits of these functions. The limits of these functions are respectively 4, 0, and negative 3. So if we do the math, that will give us plus 1. So the limit is plus 1. B is looking for the limit as x approaches negative 2 of the product of the three functions. Also, the product rule states that the limit of the product of functions is the product of the limits of the functions. So all we gotta do is just multiply the limits of these three functions. And the first function is 4, the second function is 0, the third function is negative 3. So the answer will be 4 multiplied by 0 multiplied by negative 3 is equal to 0. The last, we have to find the limit as x approaches negative 2 of a constant multiplied by a function. So limit of a constant multiplied by a function equal to the constant multiplied by the limit of the function. So the constant is negative 4, and the limit of the function p of x as x approaches negative 2 is 4. So the first term will give us negative 16, which is this right here. The second term involves a constant multiplied by the numerator, and then there is the denominator. The quotient rule states that the denominator should not have a limit that's equal to 0, and that's the case. So the limit as x approaches negative 2 of s of x is equal to negative 3, which is not equal to 0. So that's the good news. But we know that r of x equal to 0. So if we want to evaluate 5 times the limit r of x, we'll get 5 times 0, and that will be divided by -3. Since 5 times 0 is equal to 0, divided by -3 is 0, so we're just going to go ahead and divide 0 by -3, and that's going to give us 0. So the ultimate value of the limit will be -16. That's it for this long session, and thank you for your patience and thank you for watching. You have a great day.